Objectives 2 and 3 from Chapter 7 are being dealt with in two separate parts, this being Part 2. So after this video, I hope that you can determine the formula of an ionic compound formed when two given ions combine, and name an ionic compound given its formula. Chapter 7, Section 1, the stock system of nomenclature. Some elements, such as iron, form two or more cations with different charges. To distinguish the ions formed by such elements, the stock system for nomenclature is used. This system uses a Roman numeral to indicate an ion's charge. The numeral is enclosed in parentheses and placed immediately after the metal's name. Names of the metals that commonly form only one cation do not include a Roman numeral. For example, sodium, barium, or aluminum. Note that there is no element that commonly forms more than one monatomic anion. Once we understand what the stock system of nomenclature is used for, it's very easy to see when it should be used and when it shouldn't. We now understand that there are certain metal cations that form multiple charges. We see lead here and lead here. One is a +2 charge, one is a +4 charge. In general, these are far too cumbersome to simply memorize every version of them, and so we use the stock system to aid ourselves. And notice that these are going to be all transition metals, D block metals, especially in these examples. So we have tin. Tin can form +2 charge or a +4 charge. How do I know which charge it is in this particular compound? I write tin and a Roman numeral 4 in parentheses. That indicates that the tin has a +4 charge. Now, in order to balance out that +4 charge, I need 4 species of the -1. So we say tin 4 iodide. Copper, this particular copper is the kind that has a +2 charge, so we say copper 2 chloride. This type of lead is the lead that has a +2 charge, so we say lead 2 oxide. Lastly, this type of lead has a +4 charge, so we say lead 4 oxide. Now notice we have a different set of oxygens. We have PbO and then PbO2, which makes sense because this lead only has a +2 charge, so in order to balance that out, we only need 1 -2. This lead, however, is a +4 charge, so we need 2 oxides, each at -2, to balance out the lead 4. But notice that there is no difference in how we say oxide. The difference lies in saying lead 2 oxide and lead 4 oxide. Compounds containing polyatomic ions. Table 7-2 on page 210 lists some common polyatomic ions, or shown on the screen now. Note you will always have access to a polyatomic ion sheet, and so the content therein does not need to be memorized. However, you do need to understand how to use the information therein. All but the ammonium ion on that list are negatively charged, and most are oxyanions, which are polyatomic ions that contain oxygen. In several cases, two different oxyanions are formed by the same two elements. Nitrogen and oxygen, for example, are combined in both NO3- and NO2-. When naming compounds containing such oxyanions, the most common ion is given the ending ATE, 8. The ion with one less oxygen atom is given the ending ite, ITE. Sometimes, two elements form more than two different oxyanions. In this case, an anion with one less oxygen than the ITE anion is given the prefix hypo. An anion with one more oxygen than the ATE anion is given the prefix per. This nomenclature is illustrated by the 4 oxyanions formed between chlorine and oxygen, shown on the screen now, or on page 210 of your text. Compounds containing polyatomic ions are named in the same manner as binary ionic compounds. The name of the cation is given first, followed by the name of the anion. For example, the 2 compounds formed by silver, formed with silver by the nitrate and nitrite anions are named silver nitrate and silver nitrite, respectively. When more than one polyatomic ion is present in a compound, the formula for the entire ion is surrounded by parentheses. This is illustrated on page 204 of your textbook for aluminum sulfate. The formula indicates that an aluminum sulfate formula unit has 2 aluminum cations and 3 sulfate anions. At this point, I hope that you can determine the formula of an ionic compound formed between 2 given ions and name an ionic compound given its formula.